Screen two right now.
Great. Hi, I'm Ed Burke, and this is Brad Mortensen, and we are part of Lambda Labs, cohort 14. I think it's 14, or is that is that just for web, for full stack web?
Web 14x now.
Web 14x, and we are here today to discuss the conundrum that is known as climbing stairs, a algorithm that helps us understand concepts relating to recursion, delves into the Fibonacci sequence, a problem that helps us approximate the possibilities for, in this particular case, how many variations one can take in climbing a set of stairs. Given a set number of stairs, how many different ways can we climb that staircase to that step using one or two steps? So I will attempt to help Brad to walk him through piece by piece, and I think that this is relatively. I think this one, it feels good. This one is not. It didn't give me sweats the first time I looked over it, and I think Brad, we're gonna have a great time.
Yeah, so, for sure.
Without further ado, let's assume that I have a staircase of 3 steps. I will represent this with an equation, n equals 3. So if you can type that in for me.
Sure.
3 being the number of steps. So with 3 steps, how many variations could you climb 3 steps using 1 or 2 steps?
I'm just going to write this basic function real quick. How functions work. Give me a sec.
I understand. I always do this too when I'm coding in front of people.
Okay, yeah, so you said 1, 2, or 3 steps, right?
1 or 2 steps.
I'm looking at the question now. I thought it said 3, possibly 3 steps.
Is it 3 steps? Well. Okay, yeah. Well, I mean, if that's the case, then we can do this with 3 steps too.
Okay.
Well, then why don't we? Let's do it with 2 steps. That way we can understand the functionality. Because when it's 3 steps, we can add to it. It's funny because
I know how to. I've done this before, so I know how to do it the slow way. It's with using like multiple recursions of the counting step function.
Yes.
But I don't know how to do it the super fast way, so I'll show you the way I know. So first it takes in a number of steps, right? So first you can check if n is less than 0. So if it's like a negative number.
Yes.
What is it looking to return? The number of different variations of stair climbing techniques, right?
Well, it's funny because this will be my 3rd time doing this with somebody, and we've never have actually like written out a function that returns this. It's more, we've always just gone over it like conceptually and like writing it down on paper. So I guess you and I are both gonna figure this out for ourselves.
Okay. Yeah, sure.
It would return, I guess. Man, it wouldn't.
Yeah. What I'm gonna try to do is just if the number of steps is less than 0, just for base cases.
Yes.
Less than 0, return 0, and if it equals 0, I'll return 1 because if there's 0 steps. I can just So one option.
There's only one way to do it, just standing still.
Let me clean this up a little bit. Okay, those are the 2 base cases.
Yes.
Make this
Okay, so then
then what I would do is I would just call the function here multiple times, the counting stairs function recursively.
Yes.
You clean this up here too. And I would do it for every different variation. There could possibly be, so there'd be like n-1 if I were taking like 1 step at a time.
Yes.
And then I want to add that together with the amount of times counting stairs works for n-2.
Correct.
Okay, so how many should it return if it's 3 steps?
Well,
If I
let's
take one step at a time, there's 1, 2, 3. So
Mhm.
that's 1. And then with 2 steps at a time, there's 2 and then 1. Yeah, so there's only 2 different variations I can have.
Yes.
So let me call this. I don't actually need this right here anymore. Climbing stairs and then 3 steps. Let's follow that. 1. 1 variation. Does it need to end exactly?
Well, I think because you're using 3 steps, it's
Yeah, so there should be 2 though. I don't understand why that's not working.
there is 2.
Oh, I wrote if n return 1. Yeah, obviously there's going to be an n. So if n equals 0 is what I meant to put here.
Oh, good catch. Yes, correct.
Now it's coming through undefined. Counting stairs. If n is less than 0, return 0. Else, if n equals 0, return 1.
Maybe you would have to specify if n is greater than 1, greater than or equal to 1.
That's what I'm doing here, though. Or is this, maybe it's something semantic.
No, I don't think so.
No.
That's wait, that's a different result. N minus 1, n minus 2. 3 steps. 1. That's interesting.
Hold on, I think I'm not returning anything from the function as y. I want to return the total of these plus the total of these.
I think I might need to put this in parentheses too.
That might be right. Let me just. Yeah, that looks a lot better. That makes more sense now.
Beautiful. Let's see.
Unknown token. No, this is not right either. Yeah, so there's 3. Is that right?
Well, 1, 1, 1, 1, 2, and then 2, 1. Is it counting the? Is it called? Does it? I'm wondering if it's counting the variations of if you invert.
Yeah. Okay. No. It's possible variations. So three 1 steps, a 2 step and a 1 step, and then 1 step and a 2 step.
Mm-hmm. Yeah.
So yeah, if I were wanting to take 3 steps at a time, I would just have to add here.
N minus.
Counting stairs. N minus 3.
Correct. Beautiful.
And then that 4 possible variations now.
You got it, Donald Duck.
Yeah.
And so really the only thing that one needs to keep in mind with this is depending on how many variations you have, it's just a succession of counting stairs and minus, and then however many other variations, if it's 4 steps, 5 steps. I don't know who could walk 5 steps at a time, but yeah, it's just going to work recursively. It's right. all it's doing is just combining the results of say n minus 1, n minus 2. It's gonna here's how if I can share for a second. Here's how I've always demonstrated it to people when we're doing it non-functionally is if I take something like n minus 4. So well, let me start with the n minus 3. So for 1 step it would be 1 1 1 1 1, and for 2 steps it'd be 2 1 1 2, and this is if I'm taking 2 steps and not 3 step variations. So really it's just if I wanted to say n4, it's the same thing as this plus 1. So 1 1 1 1, and then same with this. You're just adding 1 to the previous results. 1 2 1, and the same could be for 5. Same thing. It's just going to be, this goes on and on and on. But you see where I'm going with it.
Yeah, and the second example, you're missing a couple cases though.
I am, but I'm just going over the broad of just how it's working recursively.
Well, I know there's another there's another way to do it with memoization, but I don't know how to do that. Do you know how to do that solution?
No, that's actually, I dipped into that last time, and then I never resolved it. We got so helplessly lost on it, and then the video was like a half hour at that point. So
Yeah, you need I know you need to cache each result and then
because you're
return
working out the previous result.
the total of the cached results. But I think you just save it into an array, so I don't think it would be terribly difficult. But I actually don't know how
That was my the initial thinking with this, was that it was going to be an array of results. But then I realized I didn't exactly need the steps themselves. All I needed was just how many possibilities there were. So the array itself was kind of beside the point.
Right.
But that's as far as I got. You were actually a lot slicker with the functional, actually building out a function for it than anybody else I've done this with. Because again, before it was just us talking broadly about the concept and how you come up with that number.
Right. Great.
So I think that's all there is to it.
Yeah,
Brad,
sounds good.
thanks for showing me how to solve that functionally, and
For sure.
and I wish you all the success in the world continuing with your education at Lambda. This is Ed with Brad. Today, what day is it? Today is the 1st of February, 2018. Have a wonderful day, Brad. Thank you.
Thank you, buddy.